Let's go ahead and start. We're continuing on in chapter 9, and we're talking about processes. And specifically here, we're focusing on process execution. There's three main types of executable programs. Binary programs, ls, find, grep. Binary program is oftentimes one that's created with a compiler, like a C compiler or something like that. We have shell scripts. This is where you create these, and we saw that in past chapters. The shell scripts may contain other executable programs. So a shell script may actually have a ls in it. And then specifically shell functions like cd and exit. Forking is the act of creating new bash shell or subshell, carried out by the fork function in the bash shell. Subshell executes the program or shell script using the execute function. Original shell uses wait function to wait for the new bash shell, subshell to complete. When done, the subshell kills itself and control returns to the original shell. You can think of this as like you got a operating system that's running, and it creates its own temporary version of the operating system to run this program in. So it's got its own environment. And then when it's done, it gets rid of all that, returns all the memory, and returns back to the original calling one. Sometimes that's the whole idea is nice, because if you're going to be modifying different items about that operating system, that bash shell or subshell, then maybe you don't want to change the original. Excuse me. And this shows you. This is process forking. So we got our bash shell, and then it forks off into another bash shell. Runs, I think I should say ls command, but does something, and then you exit out. Maybe the shell script terminates, maybe just to actually issue the exit. And then this down here is still running. So this was a temporary one that was running, but our main one's still going. Now, running the processes in the background. That's one of the benefits of this, is that you can run a process, not have it consume your operating system. So you can go off and do other things. Foreground processes, bash shell must wait for termination to display prompt and accept new commands. But a background process, bash shell does not wait for termination. So for example, if I were to sit there, and I guess I could create the one I just did the other day. I issue this and run that. I can't do anything else until this is done. So I'm just sitting here waiting. Hopefully it doesn't take that long. I won't wait any longer. That's this. Foreground process. Bash shell must wait for termination to display prompt and accept new commands. The background, though, on the other hand, you can run something in the background and then go ahead and continue working. Or in the case of a server, it can continue doing other functions. You need to omit the wait function by penning an ampersand character to the command. Upon execution, user receives bash shell prompt immediately. I don't know if they give any kind of example of that. See if I can remember where to put that. Append an ampersand character to the command. Okay, so bring that up. Pinned. Doesn't say the front. Let's put it here. Now, unfortunately, I did not redirect my my error messages, but I don't think it worked anyway. Let me see. Let me try that again. See, I could still do go ahead and do that another command. Now let's try it without. Oops. Without that. I did an ls and see how it's not. It doesn't do it until at the very end. So it was kind of hard to see with those error messages, but by putting that ampersand on there, I could go ahead and issue other commands. If I had redirected those error messages into a file, you would have saw it a lot more clearly. Jobs command lists background job IDs for processes running in the current shell. And terminated background process, send a kill signal to the PID. You can also send a kill signal to background job ID. Prefix job ID with a percent character. Probably don't have any jobs running. Yeah. Can't really demonstrate that, but. Let me try to issue that with the ampersand again. I did a job somewhere in the mix of this. Yeah, maybe it'd be easier to redirect the error. Okay. I have to Google this because I don't remember. I think it's like -E or something. But let's see, Linux redirecting standard error. This is a good one right there. Redirect standard error null. Let's see how to do that. And the black hole discards the output of the command. Run command, append. Okay, log file. Okay. Dev no. Okay, command greater than a file, 2 greater than. Okay, so 2. And actually, they have to go to the same file in this example, so &1. Then another ampersand. So let's see if that does it. Okay, so now it's running. If I type jobs, Let's try that again. Jobs. You see it's running. There's done. So that's what they're talking about, is it can run in the background. Okay. Foreground moves a background process to the foreground. Background BG send an existing process to background. Jobs command indicates the two most recent background processes. By default, commands apply to the most recent process. Time slice. Amount of time process is given on a CPU. More time slices mean more execution time on CPU. Executes faster, usually measured in milliseconds. Since there's a lot of processes running on a computer, a server, especially at any given time, it's got to allocate how much CPU processing there is. So it gives a little bit here, here, and here. And priority-wise, it may give some more to a certain application that needs that. PRI dictates the number of time slices the process gets. Low PRI is likely to get more time slices than high PRI. Cannot change PRI value directly. So I would have thought that first one would be back the other way. But set the nice value, NI, to indirectly affect priority. A negative NI value, more time slices. A positive NI value, less time slices. Processes start with NI of 0 by default. And a nice command changes the process's priority as it starts. Here's what we're talking about. So we got the negative 20. More likely to receive time slices. PRI would be closer to 0. Positive 19. Least likely to receive time slices. The PRI will be closer to 127. Then 0, the default nice value for new processes. Renice command alter NI of a process after it has been started. Only root user may change NI to a negative value. -U option, change the NI processes for all processes owned by the specified user group. May also change NI of running processes using the top utility. Press the R key, then supply the PIS and a nice value when prompted. Now, scheduling commands. We got a scheduling system maintenance command to run during non-working hours. This is nice if I'm sitting here firing off these programs, but maybe I don't want to be here at 2 a.m. in the middle of the night running programs. There actually used to be a big demand for computer operators, and that's what those people did. They worked overnight, and they ran computer processes. I doubt if you could find many jobs. Well, I shouldn't say that. Let me look. Probably don't want to advertise them here. Computer operators. Wow. 26,270. Well, I guess I don't know as much as I think I do. It's a lot of computer operator jobs. Some of these say telecommute. Because it doesn't matter where you are when you're running jobs or monitoring the system. And part of these may be, even though it's automated, the system needs to be monitored. So if something goes wrong in the middle of the night, it's fixed. They call in appropriate people or fix it themselves before the next day. Now, the goal, though, is to have it run itself, even if you have people sitting there. Um, when I was at Koch Industries, we'd have computer operators running jobs, and they'd have like a list of how they're supposed to run them. You know, run job A, run job B, run job C, type of deal. And we'd get these calls from the computer operators, and they'd say, "Yeah, I started running job A, and then I ran job C, and then I realized I forgot job B, and I went back and ran job B. Is that a problem?" It's like, oh my God. So it's like, I don't know if it's a problem or not. I'm coming in. And so you go in and you figure out what was wrong with that. They had a lot of that happen. When I was on call, I was actually probably on call for about 2 months. There was actually 3 people on call list. The person on for the current month, and then the 2 backups. And then that first person rolled off for the next month, and then that next person moved up. Well, when I was number 2 on that list, the person that was in front of me never answered his phone. I don't know how he got by with that. So I always get every call that, oh yeah, we tried to get hold of him, but he wasn't answering. It's like, okay, I'll come in. And then when I was number 1 on the list, I answered it every time during the night. Those were rough. Every other night, I averaged going in. And they had gave us a little laptop. And it's funny because laptops back then were these huge, monstrous things. And they were so slow. I think I tried to use it once or twice. And finally I realized if I just drove in the 30 minutes into work, did it, and came home, it'd be a lot faster than using that laptop. So again, scheduling is an issue. Especially if you're running something that's going to consume a lot of resources, you don't want to run it during the day. Okay, the schedule command is execute in the future at the daemon, ATD, system daemon that executes tasks at a future time. And then there's a cron daemon, cron D system, or cron D, system daemon that executes tasks repetitively in the future. So again, this is where it does repeatedly, and this is just where it just executes a task at a certain time. Now, scheduling commands with ATD, add command, schedule commands and tasks to run at a specific time, specify a time as an argument. After being invoked, the add command displays an add prompt, allows you to type commands to be executed, 1 per line. After commands have been executed, use the Control D key to schedule the commands. Let's do that. Assuming it allows me, since I'm not a root. Okay, so I'm right here, and what is this? I want to do this. ls-r, assuming it doesn't have to be a script. Garbled time. After being invoked. Yeah, it sounds like I can just do an at. Garbled time. Garbled time. Linux.com's got to be a good one. Hopefully. How do I reset the command so I can use it again? It's stuck at garbled time. So that implies it has to be a script. You can't do it in runtime or the with a prompt. Well, let's see. Okay, so V is usually verbose. At -F. So I'm going to run. I don't know what I'm going to run. Okay. So at -F, and I'm going to run the file /home/osboxes/testing.sh. And I'm going to run that at 9:55. Assuming that's the right format for the time. Looks like 24-hour time, assuming this example's correct. Okay, then it's set to run. So that's how you'd run that. I wonder why the at doesn't. How about if I put at 9:55? Will it be? There it goes. Commands will be executed using /bin/sh. And so home/osboxes/testing.sh. I run that at 11:13. Control D is what it said. There we go. So we got 2 jobs scheduled up. Okay, so that's the at. Oh, there's examples. At 10:15, you can type in whatever commands you want. Scheduled to run 4 days, so plus 4 days, plus 2 weeks, running 2 weeks, and so forth. -L view a list of at jobs. So let's look at the -L. Got 2 jobs scheduled. That's curious. It doesn't say when they're scheduled to run. Unless I had 9:55, but then I said 11:13 on the other one. -C view contents of a specified at job. Okay. -C2. Okay, and here's the run part. This is has to do with the bash. Remember how it creates uses the bash shell? So that's what's going to be set. List commands to be scheduled to add from a shell script. Okay. If the /etc/add_allow and etc/@deny files do not exist, only root user is allowed to schedule tasks using the at daemon. And here's how to give the ability to the users create those files. Both files exist. System checks the at.allow file and does not process the at deny file. what was that again? That was L. Oh, they're both scheduled for Friday. I didn't look at the time when I set that. I guess I'm not going to wait for that to run then. But they should run off. Okay. Scheduling the commands with the cron. Cron is where you want to schedule it to run every week. You don't want to sit there and reschedule it over and over. You want to set up one time and have it run for the next 2 years, for example, every week. Two types of cron tables are used by the cron daemon. User cron tables represent tasks scheduled by individual users. System cron tables contain system tasks. And you got /var/spool/cron stores user cron tables in Fedora, and /var/spool/cron cron tabs on Ubuntu systems. Then your etc crontab.file, crontab space file. I thought that was a dot, but maybe I'm wrong. Contains system cron tables. That's probably just a cron tab, I'm thinking. etc cron.d directory contains system cron tables. Here's a user cron table format. So you see that. Scheduling it. Sample user cron table entry. And user cron tables /etc/cron.allow file the list users allowed to use cron, denies list users not allowed. Both files exist. Okay, talked about that. Cron tab table used to create or edit user cron tables. -E edit cron tables in Vi. Oh, my favorite. Cron tab -E. Let's see if I have rights. Okay, I'm going to do an I for insert. And let's see if I can get this right now. A little bit tricky. And going the wrong direction. Okay. First thing we put is the first number is minutes past the hour. And then, the hour, 0 to 23. So if I wanted to run at 12 o'clock, I would put 0 and then 12. We'll see if it needs to be in any kind of special format. I don't think so. I think one space is good enough. Day of the month. So I'm going to have run 29th tomorrow. Space. Month of the year. I'm going to have run in March. I think what month it was. So 3. Then day of the week. These could contradict itself. When you don't put one in, that's where you put this asterisk you see right here. Okay, so for the day of the week, since I've already scheduled it on a specific day, I'll put the asterisk. And /home/OS boxes test.sh. How do I get out of this? Escape to exit, colon WQ for right quit. Okay, so assuming I did it right now, these commands down here, and I don't do cron tab every day, so I struggle with myself. List a user cron table -L. Okay, so cron tab. There we have it. Now going back up, our first is the minute past the hour, and I believe this implies that it'll run at minute past the hour. It'll run at 1720 and 1740. Now this range here means it's going to run 1 through 5. 1 through 5 is Monday through Friday. So you've scheduled it to run Monday through Friday. 3 and 4 are asterisked out because day of the month doesn't matter, the month of the year doesn't matter. We always want it to run Monday through Friday, period. Now let's see if I'm telling you right. Linux, cron tab, what does wheat? What does comma mean? Cron tab quick reference. Yeah, that's what it means. See, because here they got 1, 6, 12, and that says it runs in January, June, and December. So the comma means, and I thought that it was what it was, but again, my memory's kind of poor. By the way, my entry I put here should disappear because I scheduled it not to run every Monday through Friday. I scheduled it to just run that one time at March 29th at 12 o'clock. And that's noon because this is 24-hour clock. So to run this this script and do all that results and so forth. This is where you got to figure out how to notify you of whether it ran successfully. You're not going to come in and see anything on your screen. It's not going to say, hey, I ran that last night or this morning or noon or whatever. You have to figure out some kind of flag. And that's what redirecting output or just doing an echo and creating a file, you know it ran. You could have it mail you. So there's a lot of clever things you can do with that. I took a whole class at Wichita State just on, it was called Unix back then, but Unix scripting. So Linux scripting, writing scripts. And we're just doing a little bit in this class, but there's a, like I say, a whole 16 weeks worth of just working on scripts. And I think we just even touched upon it there. I think you could even do more. Let's see. Initial section of cron table specifies execution environment. Remainder of the file contains comments. Identify the format of a cron table entry. You may prefix the command within a system cron table entry with the user count that should be executed as. Cron tables located in the /etc cron.d directory are run by the system as a specified user. var spool cron. I wonder if I can actually see this. Maybe not. I want to show you the actual file, but looks like I have to go through the cron tab as this user. Let's see, where were we? Just talked about that. Many administrative tasks are performed on an hourly, daily, weekly, or monthly basis. If you have a task this type, you don't need to create a system cron table. Instead, you can place a shell script that runs appropriate commands in one of the following directories. So /etc/cron.hourly, /cron daily, weekly, monthly. So again, that's set up. You just copy your shell script over there and automatically run. So it's a little bit easier. Why sit there and schedule something on every hour when there's a folder for it? Just drop it in there. I doubt if I can see those. Let's see. Cron daily. Huh. I didn't think it would even let me into that folder, to be honest. Test.sh. So I'm gonna copy permission denied. Okay, well, it won't let me create a file in that folder. It lets me see it. See, the owner of this is root, who has full read, write, execute. All I got is read and execute, so I can't write to it. It's like I could execute something in it, like this log rotate. I don't know what it is, but looks like I could run it. I'm not going to do that because I'm not sure what it does. But summary: processes are programs that are executed on the system. User processes run the same terminal as the user who executed them, whereas daemon processes are system processes that do not run on a terminal. Every process has a parent process associated with it and optionally several child processes. Process information is stored in the /proc file system. The PS tree, and top commands can be used to view this information. Zombie and rogue processes exist for long periods of time, use as system resources, and should be killed to improve system performance. You can send kill signals to a process using the kill, all, and top commands. See, that might be a case where having a computer operator is critical. If you have a bunch of developers on your system and nobody's monitoring it, and they run infinite loops, they do weird things that consume a lot of resources, maybe you want to kill their process. The bash shell creates or forks a subshell to execute most commands. Processes can be run in the background by appending the ampersand to the command name, and we looked at that. Priority of a process can be affected indirectly by altering its nice value, ni, and commands can be scheduled to run at a later time using the at and the cron daemons. And we're done with that chapter. So I'm going to go ahead and stop the recording here. I'm going to be out of the office on Tuesday and Wednesday next week. My son's having surgery. So we'll continue again a week from today, assuming no complications with his surgery.